we will discuss selection sort this session.
Yeah.
Selection sort also order of n square. All these three algorithms, the time complexity is same. Okay.
Okay. Yeah.
So coming to selection sort, what we do is,
Yeah.
for example, we have some list of numbers 10, 1,
Yeah.
2,
Okay.
6,
Okay.
3, 9, 8,
Yeah.
1,
Okay.
5.
Yeah.
So how many elements are there? 1,
0, 1,
6, 10, right?
6. Yeah, 10.
So selection sort, what it maintains is, it maintains
Yeah.
two arrays. One is a sorted array, the other one is an unsorted array.
Okay.
Initially, the sorted array will be empty and the unsorted array
Okay.
is full. Right?
Okay.
So I'll call
Yeah.
sorted array as A
Yeah.
and unsorted array as US. Okay.
Okay.
So
Yeah.
initially, this sorted array will be empty.
Okay.
It will not have anything.
Yeah.
So something like an empty set.
Okay. Okay.
Unsorted array will have all these elements.
Okay.
Unsorted array will be something like this.
Yeah. Okay.
Now, what we are going to do is,
Yeah.
from the unsorted array, you identify the smallest
Yeah.
element.
Okay.
From the unsorted array, identify the smallest element and move to the sorted array.
Okay. Okay.
That is the logic. Okay.
Oh. Okay.
Actually, we say move to the sorted array. But actually,
Yeah.
in practical implementation, what we do is, we identify
Yeah.
the first element, okay,
Okay.
and we
Yeah.
swap that with the first element.
Oh. Okay.
So that smallest element will become a part of the sorted array.
Okay. Okay.
The logic. Are you getting?
Right. Okay.
So now, what is the smallest element in the array?
1.
1. So 1 will come here in the first position.
Yeah. Yeah.
And originally in the first position, what value was there?
10.
10. That
Oh.
will go wherever previously 1 was there.
Oh. Okay. Okay.
So
Yeah. Got it.
now the array will be like this: 7, 2, 4,
4, 6,
6, 3, 9,
9, 8,
then
10, 15.
and 5.
Okay. Yeah.
This is the end of the first round.
Okay.
In the second round, again you find the smallest element.
Yeah.
Okay.
2. Yeah.
Smallest, now the most smallest element has come here. Okay. Now
Right.
the smallest
Right.
element and swap it with the first element of the unsorted array.
Okay.
First element move to the sorted array, and that first element will go where the smallest element was there. Right?
Okay. Okay.
So now the
Yeah.
smallest element is what? 2.
2.
So after 1, 2 will come.
Yeah. Right.
Here, whatever the first element, that will occupy the place where the smallest element was there.
Right. Right.
Okay. So what will happen?
Yeah. So will it start with 4? No. Okay. So 7, 4, 5, 6, 9, 8, 10.
Good. It will start with 7, but 7 will replace 2. That's the idea.
Yeah. Right. Right.
5, 6, 9, 8, 10, 5. Okay.
Yeah.
In the next round. Now what's the smallest element?
4.
4. So 4 will come here. 1, 2. Okay. And then the
Yeah.
element will be swapped with 4.
Right.
4 has already moved here. So
Yeah.
7, now it will become 7, 5, 6,
9, 6,
9,
9,
8,
10.
10.
Oh, yeah. Yeah.
Now what's the smallest element?
5.
5.
There are two fives.
There are two fives. So we'll replace 1 5 with something else.
Okay.
Which number we missed?
Uh,
3 we missed.
after 10 only.
3 we missed.
3.
3 is
Yeah.
4, 5, 6, 7, 8, 9. Hmm. Okay. No, in the original list, I think there are now two fives. Somewhere I made.
Yeah. This 3. That's it.
There should be
Okay.
3.
Yeah.
Okay. There should be 3.
Right. Right. Okay.
Now we should change the code.
The last. Yeah. 1, 2, 3.
So at this point, the smallest element is
3.
3. Okay.
Yeah.
Now the first element will be swapped with 3. So it will become
Yeah.
4,
4, 7,
4, 7,
6,
6,
9, 8,
8, 10,
10.
5.
Yeah.
Now the smallest element is
4.
4. So smallest element is 4. The first element is all.
Yeah.
So there is nothing like.
4. So leave.
Okay. So
Yeah.
6, 9, 8,
8, 10.
5.
Yeah.
The smallest element is 5.
5.
So move 5 here. 1, 2, 3, 4, 5.
Right.
The first element is 7. 7 should be swapped with 5. Okay.
Yeah.
5 has already
9,
came
8, 10.
here. So 7 should go there.
Yeah.
So 6,
Yeah.
9,
8,
8, 10, 7.
7. Right.
Now the smallest element is
6.
1, 2, 3, 4, 5, 6.
Yeah.
First element is also 6. So there is
Yeah. So 9, 10.
9, 8, 10, 7.
Yeah.
Smallest element is
7.
1, 2, 3, 4, 5, 6, 7.
Yeah.
And it should be swapped. The first element should be
Yeah.
7. So it becomes 8
Yeah.
and
9, 8, 10, 9. Yeah.
the smallest element is
8.
1, 2, 3, 4, 5, 6, 7, 8.
Yeah.
The first element is also 8.
Yeah. So 10, 9.
8, 10, 9.
Just 10, 9, right?
Yeah, correct. 10 and 9. 8 already we moved here.
Yeah.
Now the smallest element is 9. So 1,
Yeah.
3, 4, 5, 6, 7, 8, 9.
Yeah.
That should be swapped with
10.
10. So it will have just 10.
Yeah.
Now the smallest element is, there is only one element 10
10.
that you move here. 1, 2, 3, 4, 5.
7, 8, 9, 10.
Okay.
Empty.
Right?
Yeah. Yeah.
So this is the logic. Okay.
Okay.
So basically we maintain two lists.
Yeah.
Maintain two lists. The understanding is there will be two lists, one sorted and one what you call. Each
Understand.
list will be empty and the other list will be full.
Okay.
Smallest element and move it here. Okay.
Yeah. Right.
Again find the
Right.
next smallest element, move it here. Keep on doing
Yeah.
this, right?
Yeah.
But in
Yeah.
actual implementation, what we do is we don't maintain two lists. Rather, we find the smallest
Yeah.
element and swap with the first element.
Right. Right.
Find the smallest element and swap with the second element.
Yeah. Okay.
Smallest element swap with the third element, so on and so forth.
Right.
Do this
Right.
till you reach the last element. Okay.
Yeah. Okay. Yeah.
So how we will write the code for this?
Yeah.
Example, say if you have an array like this, int a equal to
Yeah.
these same values.
Yeah. 10, 7.
Uh, let me copy 10, 7, 4, all these things.
Yeah.
What should we do? We should move from the first element to the last element. Okay.
Yeah. Yeah.
So we'll write a for loop
Okay.
I equal to 0,
Yeah.
I less than a dot length
Okay. Yeah.
I plus plus.
Yeah.
Now we should find the smallest element, and that should be swapped with the ith.
First element. Right.
Initially I is 0. Okay.
Right. Right.
So how will we find the smallest element? The logic to find the smallest element is
Yeah.
there a variable called min.
Okay.
Initially we will assume the ith element as the smallest element.
Okay.
It's an assumption. Min equal to a of
Yeah. Yeah.
first round I is 0. It means I'm
Yeah.
assuming that the first element is the minimum element. So
Okay.
it is 10. Okay.
Yeah. Yeah.
And also let me note down that index.
Okay. 0.
So what do you call? So index of, we'll call it as index of minimum element. Okay.
Okay.
Index of
Yeah.
minimum element equal to I. That also we are noting.
Yeah.
This is,
Okay.
but my assumption may be wrong.
Right. Right.
For that, we are writing another for loop. Okay.
Okay.
For int
Yeah.
j equal to I plus 1.
Okay.
For int j equal to I plus 1. Again, j less than
Okay. Length. Yeah. You got it.
a plus plus. Right?
Yeah.
Now we are
Yeah.
going to compare every element with the minimum element and
Okay.
whether that element is less
Yeah.
than minimum or not.
Okay.
Suppose if that element is less than minimum, then we will change our assumption about minimum.
Right. Right.
Are you getting? So here
Got it. Got it.
we check if a of j,
Yeah.
a of j is less than min.
Right.
I found an element which is less than my assumed minimum element. Okay.
Yeah.
Now my
Yeah.
assumption get defeated.
Yeah.
I change my assumption. Now I assume
Okay.
a of j as minimum,
Okay. Okay.
and I'm noting down its index.
Yeah.
Index of minimum is equal to j.
J. Right.
Like this, you do the comparison with all elements from
Okay.
I plus 1 to last element.
Okay.
When this loop finishes execution, no, obviously
Yeah.
smallest element,
Yeah.
and that smallest element will be available in min.
Right. Right.
So we have the index. Its index is available in index of min.
J. Right.
Now we need to swap this element, whatever the minimum element, and also we know the
Yeah.
index of that element. Okay, that element
Yeah.
is swapped with ith element.
Right. Right.
Are you getting? So
Got it.
we will write outside the loop. Okay.
Okay.
So int p is equal to
Yeah.
a of I,
Yeah. 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 Right.
and a
A
of
of
I is
I.
equal to
A of J.
not a of j, a of index underscore min. Okay. So
Okay. Same thing. Yeah.
are you getting? So j will be that whatever the current
Oh,
minimum, that will be in index underscore min. Right?
okay. Okay. Yeah. Yeah. Okay.
A of I is equal to a of index underscore min, and a
Right. Right.
index underscore min
Right.
equal to t.
Yeah.
So like this we do for every iteration. So in the first
Okay.
iteration, it will find the minimum element and swap with the zeroth element.
Right.
Then it will find the next minimum element and swap with the first element,
Right.
and so forth it will do.
Okay.
So this outer loop, you need not go up to length. Even you can stop up by length minus 1 also. That's also fine.
Okay.
If you go up to length also, no issue.
Yeah. Right.
Now we can close it, right?
Yeah.
And then we can
Yeah.
display
Right.
out.println
Yeah.
the sorted elements or
Yeah.
data for loop for is equal to 0
Yeah.
dot
Yeah.
print
Yeah.
a of I plus give some space.
Okay.
So close this
Yeah.
and you can
Class.
public class selection sort
Yeah.
void main
Yeah. String.
this is the end of main method.
Yeah.
We should also end the class.
Okay.
This is the end of the class.
Yeah.
So let us check. So let us save
Yeah.
this.
Selections or demo.
Yeah, selections or demo.java. .java.
Java selects. Oh.
I think that index underscore min is not defined.
Okay. Oh yeah.
So we can define it here.
Yeah. Intent. Yeah. Yeah.
Build, execute.
Right. Okay.
So this is the logic for selection sort.
Yeah. Okay.
So all these three sorting techniques basically
Yeah.
they work on the their time complexity is order of n square. Okay,
Yeah. Yeah.
fine. So next, now we will move on to data structures.
Right. We have. I'll tell you what we have in there.
Hmm.
Let me see.
Stack is there. Just now I saw your book. Right? Stack queue,
Yeah.
infix
Stack
to
and queue as
postfix,
well.
infix to
Yeah. All of that
postfix.
is binary trees.
Hmm.
That's it.
So you tell me, are they asking any programs on infix
No.
conversion?
No programs. Only conversions are there.
Only conversion, right?
Yeah.
Okay. Hmm. What about stack?
Program.
Stack, are they
Yeah,
asking
program.
for queue?
Yeah, they asked.
Programs are there. Okay.
In the model paper I sent you, they asked a question based on stack. That is the last question. That's for 4
Oh,
marks.
okay, okay. Mm-hmm. Okay, anyway. So we'll start with stacks. Okay.
Yeah.
Data structure. So how do we define data structure? The data structure
Yeah.
is a method of systematically storing the data, or
Okay.
different operation, different data
Yeah.
structures may be appropriate. Okay.
Okay.
It's not
Yeah.
that you can use the same data structure for every task.
Yeah.
You may use,
Okay.
but it may increase the complexity.
Okay.
And is there any questions in linked list?
No, they didn't ask linked list questions.
Oh, okay. So, so what is a, say for example, array is a data structure
Yeah.
and stack is a data structure.
Yeah.
Queue is a data structure.
Right.
Linked list is a data structure.
Yeah.
Tree is a data structure.
Yeah.
Tree is a data structure.
Yeah.
Graph is a data structure. All these are different
Yeah.
structures. To represent,
Okay.
so for different types of problems, uh,
Yeah.
we need to represent the info with different data structure. Okay.
Okay.
Before solving a problem, you need to identify what is the right data structure, and then you have to solve the problem.
Okay. Okay.
With the right data structure, then your problem will become very simple. You can easily solve the problem.
Right.
It is
Right. Right.
having the right tool in your hand.
Okay.
Otherwise, it means you are trying to operate with the wrong tool. Okay.
Okay.
Say, for example, there is some nut, screw, or bolt you want to open, want to remove that.
Okay.
Then you need a correct tool. You need a screwdriver or you need a spanner like that, right? If you
Right. Right.
do with a knife or if you do with
Yeah.
other device, then you may try for 1 hour or 2 hours, it may not happen.
Right. Right.
If you have the right tool, the same task may be completed in 5 or 10 minutes or less than that. Okay. So that is the role of the data structure. Before
Okay.
the problem, we need to identify which data structure would be appropriate for this, and you have to use.
Okay.
Okay.
Right.
Sometimes in real world, you may not even have
Yeah.
data structure. Then you can create your own
Okay.
data structure. Programming
Oh, okay.
provide that ability also. You can,
Right.
because you may know these are the data structure, but this is the operation I want to do. None of the data
Right.
is available. So you can also
Right.
create your own data structure. Initially, it may take
Okay.
time, but once you have done, then you can keep using it. Okay.
Okay.
So,
Yeah.
so that is the this is the top level understanding of data structure, right?
Right.
Coming to stack, stack is one of
Yeah.
the commonly used data structure in computer science. It has
Okay.
applications.
It has?
It has several applications
Okay. Okay.
in computers, right?
Yeah.
So stack is a LIFO data structure. It's called as
Okay. Lift.
LIFO, which means
Okay.
lost in first out.
Okay.
Is lost in first out. That is the element
Right.
that enters the stack at last will be the one which will come out first.
Oh, okay.
Okay, the element that enters the stack at last will be the one which will
Yeah.
come out first.
I'm got it. Okay.
Say for example, I have a stack of size 5, right?
Yeah.
So
Yeah.
it can hold 5 elements, right?
Yeah.
So
Yeah.
initially the stack pointer will be, so basically stack is an array. It's nothing else.
Okay.
But the
Yeah.
way in which we access it differs. Okay.
Oh, okay.
So to access the stack, we use only one pointer, one reference or one pointer. And this pointer
Okay.
is stack pointer, or we just call it as SP. SP stands for stack
Okay.
pointer.
Okay.
Stack is empty, SP will be -1.
Okay.
Initially, stack will be empty. So SP will be.
Yeah.
Okay, so this is one way to check whether the stack is empty or not.
Oh, okay.
And now we are assuming a stack of size 5. Let us assume
Yeah.
our stack is of size 5.
Okay.
So, so we'll keep n. N represents the size of the stack. Okay.
Okay.
Totally, it can hold 5
Yeah.
elements,
Right.
but basically it is an array. So it will store elements from 0 to 4.
Yeah. Right. Right.
You getting? So,
Yeah.
so this is if sp is -1, it means stack is empty. At this,
Right.
if sp is equal to n minus 1, it means
Yeah.
okay.
It means.
It means stack is full. Stack is full.
Oh. Okay.
Already it is full. You cannot add any more elements. Are you getting?
Okay. Okay. Okay.
Right? Fine. So with this understanding, let us assume. Say
Yeah.
I have an empty stack which can hold
Yeah.
5 elements, right?
Okay.
From 0
Yeah.
to 4 position. Okay.
Okay. Yeah.
Stack you can perform two operations. The first operation
Yeah.
is called as push.
Push. Okay.
Push is called as adding an element to the stack.
Okay.
Adding an element to the stack is called as push. Okay.
Yeah.
So whenever you
Yeah.
push something, what happens? Stack pointer will first increment.
Okay.
Stack pointer will first increment.
Yeah.
And then the
Okay.
element will be added to that particular position.
Okay.
But before pushing, you need to check whether the stack is full or not.
Right.
Already full, you cannot push.
Okay.
Okay. So
Right.
these are the things you need to do. So before push, what you need to check whether stack full or not.
Yeah. Yeah.
If stack is not full, then you can go
Yeah.
pushing. Okay.
Okay.
If it is not full, so our
Right.
check not stack full. If stack is not,
Okay.
then increment the stack pointer
Okay. Okay.
at sp by sp plus plus. So initially sp
Right.
minus 1 means sp will become 0, right?
Okay. Okay.
Let us assume
Yeah.
the name of our stack is stack only. Then
Right.
stack of sp, right?
Yeah.
Basically, it's an array. So stack of sp is
Right.
whatever the item you want.
Yeah.
Okay. So
Right.
item means this is what we need to do. Pushing means adding an element to a stack. Before pushing,
Right.
to check whether the stack is full or not. If
Full
it's
on.
full, you cannot push. If it is not,
Okay.
increment the stack pointer and add the
Okay.
item location. Right?
Okay. Yeah.
Another operation that we can perform on stack is pop.
Pop. Okay.
Pop will always remove the top element from the stack.
Oh. Okay.
It will only remove the top element. Okay.
Okay.
And again,
Yeah.
stack pointer will always point to the top element.
Okay.
We always point to the top element.
Right.
You cannot perform pop if the stack is empty.
Okay.
Already, if the stack
Okay.
is empty, you cannot remove anything, right? So
Okay. Yeah.
before popping, you need to check if stack is not empty. Okay.
Right.
If stack is not empty.
Right.
If it is empty, you cannot pop. If it is not empty, then return
Yeah.
the topmost element, right?
Okay.
So return
Yeah.
whatever the top element, return that. So return
Okay.
stack of top.
Right.
SP is pointing to the top element always, right?
Yeah. Right. Right.
After returning the topmost element, then it means we have removed
Yeah.
the top element.
Okay.
Then decrement the stack pointer.
Okay.
This is the core logic.
Okay. Okay.
Push. Before pushing, we need to check whether the stack is full or not. If it is
Right.
full, you cannot push. Right?
Right.
If it is not full,
Yeah.
increment the stack pointer and add
Right.
item to that location.
Yeah.
Pop, we need to check whether the stack is empty or not.
Right.
Only if it is not empty, we can pop. Now remove the top element
Yeah.
and decrement the.
Okay. Right. Right.
Now let us try to understand the stack. Say, assume that our stack size is 5. Okay.
Okay.
So
Yeah.
initially, SP is -1, which means stack is empty.
Yeah.
Now what I'm going to do, say I'm adding one element. Say I'm adding
Okay.
to the stack. So
Okay.
first what will happen? SP will increment.
Yeah.
Whether the stack is full or not. No, it's not full. So increment SP.
Right.
SP will be
Right.
0.
0.
So in the
Yeah.
0th location, 10 will be added.
Okay.
Are you getting?
Okay. Yeah, got it.
Then say I want to push 12.
Okay.
Whether the stack is full or not. Okay.
Right.
In our case, full means what? SP is 4, then it is full.
Right. Right.
N minus 1. Right?
Yeah.
So it's not full.
Yeah. So it's,
Again
yeah.
increment SP. So SP becomes 1.
Right.
So in the first location, add 12.
Well, okay. Okay.
So once again, say I want to push some other value 4
Right.
or not.
SP is equal to 3.
Yeah, it's not.
Sorry, 2.
Yeah, SP equal to 2. And in the second
Yeah.
location, push 4.
Yeah.
So now I want to push something 7. Again, stack is not,
Oh,
SP is not 4.
yeah.
Increment
Yeah.
SP. SP becomes,
Right. 3.
so 7 will come here.
Yeah.
So now I want to push 5. Still
Yeah.
not full. So increment SP.
Yeah.
So
Right.
it will become 4
Right.
and push 5 here. Okay.
Yeah.
So
Yeah.
now I am trying to push one more element. Push 11.
Yeah.
What will happen? Will it push or not?
It won't.
It won't push because already stack is full.
Yeah.
Equal to n minus 1. So now it won't.
Yeah.
Now you can only
Yeah.
pop. Now if I,
Yeah.
it will return which item?
Okay.
Pop will always, SP will always point to the top element. Okay.
Right.
So
Okay. So
before
5.
before popping, it will check whether the stack is empty or not.
Yeah.
Whether
It
the
is
stack is
full.
empty or not, only if SP is minus 1, stack is empty. SP is not minus 1.
Right. Right. Okay.
So
Oh, okay.
return stack of SP. What is stack of SP? What is stack of 4? 5.
Yeah.
Are you getting?
Got it. Okay.
It will return 5. It will return.
Okay.
After returning 5, what will happen to SP?
3. It'll become 3.
SP will become 3. Okay.
Yeah.
Once again, if you pop, what it will return?
Yeah. 7.
It will return 7. Okay, because current
Yeah.
top is 7. And again, SP
Right.
come.
2.
Once again, if I pop,
4 will return.
yeah, it will return 4 and SP will become
1.
1. Once again, if I pop,
It'll return 12.
it will return 12 and SP will become
0.
0. Once again, if I pop,
It'll return 10.
it will return 10 and SP will become
Minus 1.
minus 1. Can I pop again?
No, it's empty. No.
No. If you try to pop once again, now it will say that stack is empty.
Right. Right.
Okay.
Yeah.
So you may wonder where stack is used in computers.
Daily life. Yeah.
Uh, So, for example, in an expression, whether
Mm.
whether the parentheses, whether the all
Yeah.
parentheses were properly opened and closed or not, that checking
Right.
is done using stack. Okay.
Okay.
Or even if you
Okay.
write a program for that matter, all open
Yeah.
parentheses should be closed. Okay, you cannot.
Right.
So there should be some logic to check that.
Right. Right.
So that is actually implemented using stack.
Okay.
And function call and return. Stack is heavily used in function call and return. The concept
Okay.
function call and return actually it works through stack. Okay.
Okay.
We
Yeah.
cannot discuss the details of that because that itself is a very lengthy topic. But these are the
Okay.
options of stack. Okay.
Right.
Because
Right.
all a function control will be transferred somewhere else. And again, it should
Okay.
go to the right part where it has previously left over. These
Right. Right.
are actually working properly because of the stack data structure.
Okay.
So these are some of the applications of stack.
Right.
Now let us discuss the code for stack.
Yeah.
So basically stack is an array, nothing else.
Yeah.
Okay.
Yeah.
So we need an array. So let us assume
Yeah.
stack int
Yeah.
of 100
Right.
or not 100 or 5 so that we can see.
Okay.
So
Yeah.
stack full, stack empty, all those things, right?
Okay. Okay.
So
Yeah.
in this case, what is the size of the stack? What is n?
Hi.
5. And stack pointer sp should be initially
-1.
-1, which means stack is empty. Okay.
Yeah.
Then what we are going to do is,
Yeah.
yeah. So we need to perform push and pop operations. Okay.
Right.
Say this is a class like this.
Yeah.
Like class,
Yeah.
and these variables we are declaring here. We are declaring stack, n,
Right.
sp, all these are declared here, right?
Right. Right.
And then somewhere here comes the main method,
Yeah.
like static void main
Yeah. Yeah.
in args.
Um, right.
So in main method, what we are going to do is we are going to just push and pop some elements,
Okay.
and we are going to check whether the push is successful or not. Okay,
Right. Right.
we'll be writing some method for pushing and
Yeah.
popping. Before
Okay.
that, but I'll write the code for main method. Okay,
Okay.
write the
Yeah.
method for push and pop. Right.
Yeah.
So here, what I'm going to do is, so
Yeah.
we'll create an object for the class stack demo.
Okay.
Demo sd is equal to new.
Yeah. Demo. Yeah.
I'm saying sd dot
Yeah.
push of 100.
Yeah.
I have a push method, it should push properly.
Right.
sd dot push of say 29,
Yeah.
and then sd dot push of 32,
Yeah.
and sd dot push of 12.
Yeah.
All these push operation will be successful. It will say that
Right.
this is pushed like that. Okay.
Okay.
Then
Okay.
sd dot push of say 89.
Yeah.
Okay.
Okay.
Can
Yeah.
I push any more item?
That's it. No.
No. So now if I try to push, no, I'm trying
Yeah.
to push sd dot push of say 56. It will say stack
Right.
full. You
Will
can't,
say stack.
stack is full
Okay. Okay.
because already you have pushed 5 elements. Are you getting?
Right. Right.
So after
Yeah.
fifth element, if you try to push, it will say stack is full. Are you getting?
Okay. Okay. Right. Got it.
Similarly, now we can pop.
Okay.
So when you
Okay.
pop, it will give the topmost element. What would be the topmost
Right.
in this case?
100.
Not 100. 100 will go where? Because of
Eh,
this, stack is called last in first out.
right. Right. Okay.
So what will be
So
the
it'll be
topmost?
18.
89. Okay. So
Yeah.
give 89.
Yeah.
If I give pop, it will give what?
I'll okay. Pop again. You have to give it 5 times, right?
Yeah, we should give 5 times.
It'll execute.
Yeah, what output it will give?
It will keep on remove. So it'll for the first one it'll give 12.
First one 89, not 12.
Sorry, 89. Then
Second,
12. Then 32. Then 29. Then
yeah,
100.
okay.
Yeah.
So you remember the logic. Once the stack is
Yeah.
full, SP will be 4. Okay.
Yeah. Right.
You give the
Right.
first pop, the topmost element, fourth element will come out, which is 89.
Right.
Then SP
Okay.
will
Okay.
decrement to 3.
Yeah.
So now second pop will give 12, right?
Right.
Again
Okay.
SP will decrement to 2.
Yeah.
Once again if I give pop, it will give
32.
32. Again if I pop, it will give
29.
29. Again if I give pop, it will give.
100.
Once again if I pop,
Stack is full.
it will say stack is empty.
Sorry, empty. Yeah.
Are you getting? Okay.
Yeah.
So this pop I can write in between also. After pushing 2 elements, I can pop. After pushing 3 elements, I can pop. Anything you can do. Are you getting?
Okay. Yeah.
So this is what we are going to do. But to do,
Okay.
we need to include the push and pop method, right?
Okay.
So first
Yeah.
let me write the push method.
Right.
I push int some element x. Okay. When you cannot push,
Yeah.
when you cannot push,
When it is empty.
no, push.
Pushes it need not be empty, right? It should be push. Okay.
For
One
pushing,
second.
when push is not possible.
Push is not possible when the stack is empty.
No. When the stack is empty, you can push. Push means what?
When you're putting an element.
You are putting an element. If stack is empty, why can't
Yeah.
you put?
Yeah, right. Sorry, when it's full.
When it is full, you cannot push. Okay.
Yeah.
Before
Yeah.
pushing, we need to check whether the stack is full or not.
Right, yeah.
Check whether the stack is full or not. If SP equal to n,
Yeah.
then stack is full.
Right, yeah.
If SP is equal to n minus 1, then say that system.out.println
Yeah.
out.println stack is full.
Yeah.
And return, because we don't have any
Yeah.
job here.
Right.
We cannot push.
Yeah.
Suppose if this condition is not satisfied, then it means that stack
Yeah.
is not full. Okay.
Yeah.
Not full, then you can push.
Okay.
To increment the stack pointer, SP++.
Yeah.
If initially SP is minus 1, it will become 0. Right?
Right.
Then
Yeah.
stack of SP
Yeah.
equal to X.
Yeah. Right.
That's all. This is the logic for push.
Okay.
Okay.
Yeah.
For pop, pop should return something.
Right.
We say int pop.
Okay.
Int pop. Okay.
Yeah.
So when you cannot pop,
When it is empty.
when it is empty. So how do you know whether the stack is empty or not?
If the SP is equal to -1, it's empty.
Yeah. If SP equal to minus 1.
Yeah.
Initially SP is what? Minus 1. Minus 1 means stack is empty.
Right.
Are you getting? Okay.
Yeah, got it.
So if SP is minus 1, then we say that
Yeah.
system.out.println
Yeah.
stack is empty.
Yeah.
And it should return some value. So we return minus 1.
Right.
If stack is empty, we return
Right.
minus 1. Okay.
Right. Yeah.
Otherwise, if stack is not empty,
Yeah.
then what should we do? Then we should return the topmost element. After that, you should
Yeah.
increment the stack pointer. Are you getting?
Right.
Uh,
Okay.
so, but after returning, you cannot decrement.
Okay.
You return, control will go out, right?
Yeah. Right.
So that what
Right.
we'll use some temporary variable. Int x is equal to
Okay. Yeah.
stack of top, right?
Okay.
So now the
Yeah.
element we are moving to, we are keeping in
Yeah.
x.
Okay.
Top element
Yeah.
in X, then decrement top,
Right.
then
Right.
top. Okay.
Okay.
And then return X.
Yeah. Right.
Is that okay?
Yeah. Got it.
Then return X. Then close this.
Yeah.
Okay.
Okay.
Now here we have returned pop
Yeah.
sd.pop. Okay.
Yeah.
But we'll not say just,
Yeah.
we'll say system.out.println pop because it should return that value.
Okay. Okay.
System.out.println pop.
Stop. Right.
Or we'll say, what do you call, the popped value is.
Okay. Plus. Yeah.
Like that, we will give 6 times. 5 times it will be
Right.
successful,
Okay.
but the sixth one will be failure, right?
Okay.
It
Yeah.
is sd.pop.
Yeah.
So this file should be saved as
Uh,
demo.java.
the mode. Yeah.
In Java, you have to declare like this: int stack equal to new int.
Yeah.
Okay.
New int. Okay.
Top is not. It's not top. So it is SP, right? Some places I have used top,
Oh.
so it should be SP. Right? So sometimes you can also use, say, either you can use SP or top. It's up to the, but you should be consistent with the variable.
Okay. Uh, Stop again. Oh, the problem. Okay.
Push
Yeah.
also we can write. In push also we can say that some element is successfully pushed. Okay.
Right.
So here
Right.
say that uh, dot out dot println
Yeah.
push item
Yeah.
plus x. So x is
Yeah.
plus.
Yeah. Yeah.
So now we'll get some meaningful out.
Right.
In compile
Yeah.
and execute.
Yeah. Well. Yeah.
Oh,
The things that I.
back demo.
Yeah.
Okay.
Okay.
Pushing all these things. So when you try to push sixth item, it is saying stack is full. Okay.
Right. Right. Yeah. Okay.
Stopping 89, 12, 32, 2900. Then it is says
Okay.
okay.
Right. Right.
It
Okay.
will return -1. So -1 represents
Right.
is empty, right?
Right. Okay. Yeah.
So this is about stack.
Yeah.
Okay, Nivedita, we'll stop here.
Okay. Evening, sir.
Yeah, evening 8 will say.
Yeah. Right.
Okay, thank you.
Thank you, sir.